Having completed the lesson on the use of a loading manifest and centre of gravity envelope for a light aeroplane, we will look at applying the same method to a multi-engine piston aeroplane. Using given data, we will resolve the takeoff and landing mass and corresponding centre of gravity, checking that they are in limits as per CAP 696. For this exercise, we will use fictitious data for entering into the loading manifest, figure 3.2 in the CAP, multi-engine piston 1. In the manifest for this example, the values under items arm and moment from basic empty mass down to baggage zone 4 are entered. The maximum permissible mass values for this aeroplane are below the manifest. The mass and moment columns can now be totalled to give the zero fuel mass and moment. The zero fuel mass arm is calculated by dividing the total moment by the total mass and the result entered in the table. Now we can enter the fuel, which is given in gallons. The conversion to mass is achieved by multiplying volume by 6 pounds per US gallon, which is allowed for in the CAP, section 3, page 2, under standard allowances. In this case, we have 90.8 US gallons, which equates to 545 pounds. Totalling the mass and moment columns now will give the ramp mass and moment, and dividing the moment by the mass will give the ramp mass arm. The fuel allowance for start, taxi and run-up is a standard value from the CAP. The takeoff mass and moment is calculated by subtracting the start, taxi and run-up allowance from the ramp mass. To arrive at the mass and moment for landing, the fuel burn-off must be entered in the manifest, and because it is given in volume, 75 US gallons, it must be converted to mass, giving 450 pounds, using the standard conversion in the CAP. The landing mass and moment is calculated by subtracting the fuel burn-off mass, 450 pounds, and moment, 421.2 pound-inches, from the takeoff mass and moment. This completes the loading manifest for the multi-engine piston. The relevant data will be entered into the centre of gravity envelope to establish the takeoff and landing centre of gravity. We can now enter the values from the loading manifest into the centre of gravity envelope in CAP 696 for the multi-engine piston, and check that the mass and centre of gravity for takeoff and landing are within the limits of the envelope. Enter the takeoff mass of 4,748 pounds and centre of gravity arm, 93.9 inches, from the manifest into the centre of gravity envelope. In the envelope, check that the mass and centre of gravity for takeoff are in limits. Using the landing data from the loading manifest, enter the figures for mass, 4,298 pounds, and arm, 93.9, and check that the landing mass and centre of gravity are in limits. It is not always necessary to plot the zero fuel mass and centre of gravity, but in this case we can do it and observe that the results indicate that they are both within the limits in the envelope. Once the takeoff and landing centres of gravity are calculated, the results could be checked to see if they are within the limits published in the aeroplane flight manual. However, by using the graphical method, we have an instant check that the limits are not exceeded. We have now completed 2 exercises involving the completion of a loading manifest and centre of gravity envelope to establish the mass and centre of gravity of an aeroplane and check against set limits. You should practice this skill with additional exercises.